proceed to the second part of this lecture, which is packaging materials. Packaging materials include the glass packaging, aluminum foil packaging, plastics, paper and paperboard packaging, and also corrugated board packaging. But in this lecture, we will only discuss about the first three packaging. The first packaging material is glass packaging. It is the oldest packaging material, and it is made of a silica, which is the principal component of the sand. So the mixing of the silica with the various compounds can alter the properties of the glass. For example, if aluminum oxide is mixed with the silica, it will improve the durability of the glass. And if the glass is treated by the titanium or zirconium, it will increase the glass strength. And for the high heat shock resistant glass, it is mixed with the boron compound such as borax or boric oxide. For manufacturing the glass that have the amber color, the glass should be mixed with the iron, sulfur, and carbon. So amber glass bottle can filter out the ultraviolet light, and it is used primarily for the UV sensitive product such as light sensitive vitamins and also antioxidants. There are 5 advantages and 3 disadvantages of glass packaging. For the advantages, the first one, it is inert to most chemicals, so it is compatible for most products. The second one is it is impermeable to gases and water, so it is suitable to be used for the product that need the protection from the spoilage of oxygen and moisture. The third one is about the appearance. The glass packaging can change color and it also can be transparent. Other than that, it also can be molded into various shapes, right? Round shape, cylinder shape, and other shape of glasses. The fourth advantage is the resistance to pressure and heat. So, glass packaging is appropriate for the product that require partial vacuum to prevent microbial growth. And it also appropriate to be used for the product that need terminal sterilization. The last advantage of the glass packaging is it can be repeatedly recycled. So the color of the glasses is heated until molten to reform into the container without compromising the quality and the strength of the glass packaging. As for the disadvantages of the glass packaging, the first one is the glass packaging have high density, so it can cause heavy packaging and lead to the high cost of the transportation. The second disadvantage is brittle quality, so the glass packaging shatter when broken and produce sharp fragments and splinter, which causes serious safety hazard. When the glass packaging have faulty in the processing, usually it will cause cracking and chipping. This cracking and chipping will cause the glass packaging to be vulnerable to the breakage. The last disadvantage is costly. The raw material itself, the raw material to manufacture the glass is cheap, but the heating cost is high and affect the total cost of the glass manufacturing. Other than the manufacturing of the glass, the recycle of the glass is also have a high cost, but it is not because of the direct cost of the recycle, but it is because of the cost due to the transportation because of the high density packaging. This is the example of the bottle glass packaging that usually be used in the nutraceutical product. Now we go to the next packaging material, which is aluminum packaging. Aluminum packaging is widely used in the form of foil for the packaging of the nutraceutical product. The thickness is around 6 to 150 microns, And the general characteristic is the silvery white metals, and it is lightweight. It is resistant to corrosion, but only by passivation. If the aluminum packaging is not undergo process of passivation, it will not resistant to the corrosion. It's also ductile and malleable at normal temperature, so it is easily to be formed into any shape, and it is also non-magnetic, but a good conductor for heat and electricity. There are several advantages of aluminum foil packaging. The first one is about the appearance. Aluminum foil packaging have bright, reflective, and gloss appearances that make it attractive and able to attract customers' eye, so it can act as silent salesman. Secondly, it is about the stability. The aluminum foil packaging is stable and resists oxidation since it can form oxide layer when exposed to air, which prevent oxidation. It is also inert with most chemical, thus it is compatible with most of the nutraceutical products. Thirdly is about the barrier function. Similar to glass packaging, aluminium packaging also provide complete barrier to gases and water, which is suitable to be used as the packaging of air or moisture sensitive product. It is also suitable to be a packaging material for light sensitive products since it reflects light, so it can hinder the light from in contact with the our product. The next advantage is about the hygienic. The surfaces of the aluminum foil packaging is non-absorbent, thus it can be easily cleaned and sterilized. The fifth advantage is the formability. As I mentioned in previous slide, aluminum general characteristic is ductile and malleable, so its ductility make it easy to be formed into any shapes. It also possessed excellent deadfall properties, meaning that it can provide a complete closure if it is folded, and it allows complete closure after the packaging is opened. Its friability also can be exploited to be used as a blister packaging. The sixth advantage of the aluminum packaging is recyclability. The aluminum foil packaging can be recycled at very low cost, which only used up 5% of energy in the recycle process. The last advantage is about the heat tolerance. The pure aluminum's strength is uncompromised at up to the temperature of 150 degrees Celsius. There are a few disadvantages of aluminum foil packaging. The first one is it is easily torn and punctured. The particular problem is also known as the flex cracking, in which it is easily split when folded or stretched. But this particular disadvantage can be overcome by coating and lamination process that able to increase its strength. This problem also can be an advantage to some packaging function, for example, the blister packing. It needs to be easily torn or punctured for complete containment and easy opening to get the product. The second disadvantage is a problem during the aluminium processing, which is called pinholing. Pinholing is an appearance problem that makes the surfaces of aluminum foil to have many tiny dents or holes, like it had been pressed by needles throughout the surfaces. This problem cannot be solved except for controlling the impurities and process variation during the aluminum foil manufacturing process. These are the example of the aluminum foil packaging that have been used in the nutraceutical application. Now we continue with the next packaging materials, which is plastics. Plastics are generally lighter and it is more easily formed into different shapes as compared to glass packaging. Commonly used plastic packaging are polyethylene family of plastics, or we call as PE, polypropylene, PP, polyethylene terephthalate, PET, polyvinyl chloride, PVC, and polystyrene. First, we go to the polyethylene family of plastics, PE. PE is classified according to the density. The lower density of the PE, meaning that it have more branch chain in the structure, because if there is more branch chain, there is also less of this chain can be packed together. So it can have the more steric hindrance that leads to the lower density of the materials. The denser the PE, the it will cause high tensile strength and have high barrier to the moisture and gases, and also have higher heat resistance and opacity of the packaging. There are three common family of polyethylene. The first one is low density polyethylene, LDPE. LDPE have a mix of long and short branch chain, making it semi-transparent or translucent. It is also soft and flexible with good puncture resistance. It also have a fair moisture barrier and poor oxygen barrier, so it is not suitable to be used to pack the product that have the oxygen sensitive or moisture sensitive. The LDPE also soften at around 100 degrees Celsius or lower. As for the second family, which is LLDPE, linear low density polyethylene, it has similar properties to LDPE but have a tougher strength with a slight better barrier properties. So it is more have a moisture barrier and have a better oxygen barrier. Its appearance is a little or more transparent than LDPE. As for the LDPE, it is semi-transparent, and for the LLDPE, it is more transparent. Apart from use as a primary packaging, LDPE and LLDPE also can be used as the secondary or tertiary packaging as a stretch film, collection, and shrink film. The third common family of polyethylene is the high density polyethylene, or we call as HDPE. HDPE have a highly linear structure, and it has a highly unbranched structure, which makes it opaque, rigid, and higher tensile strength than LDPE and LLDPE. It has also a good moisture barrier and a fair oxygen barrier. So, unlike LDPE and LLDPE, HDPE can be used to package the product that have moisture sensitive properties. HDPE also withstand a higher temperature than both family mentioned before, which is up to the 135 degrees Celsius temperature. Now we continue to discuss other plastic, which is polypropylene. PP have a lowest density as compared to the other common plastic packaging, so it provide an economical advantage in which the transportation cost will be much lower than the other plastic. PP existed in three forms, which are isotactic, atactic, and syndiotactic. The three forms are differed in the asymmetric carbon orientation. So the isotactic means that all asymmetric carbons in the polymer or in the plastic have the same configuration. Meanwhile, the syndiotactic means that the asymmetric carbons have the alternating configuration. And the last one is the atactic. It is mean that the asymmetric carbons have a random orientation. So the commonly used PP plastic as a packaging is isotactic because it will provide clear properties. The PP plastic also have a tougher and stiffer properties than the PE family, and it also provides a good resistance to deform or cracking over a long period of exposure to a high levels of stress. It is also provide a good barrier to moisture and can withstand a temperature of up to 160 degrees Celsius higher than the PE family can withstand. But at a very low temperature, it will become brittle, so it is not suitable for use in a long-term deep freeze condition. As for the next plastic variation, which is polyethylene terephthalate, PET, it is available in two forms, which are amorphous PET and crystalline PET. The commonly used one is amorphous PET. It has a higher in gas barrier function as compared to the most of the common plastic packaging, including the PE family and PP family. But the moisture barrier is just about the same as the LDPE. 90% of the polyethylene terephthalate used in the packaging for bottles, for example, the mineral water bottle. The PET use is popular now because of the good oxygen barrier function, which provides a protection against the degradation of the oily product. Okay, these are the examples of the plastic packaging usually used in the nutraceutical product. The final part of this lecture, which is a packaging closure. The closure is defined as any method for closing a pack so that the product is properly contained and protected. There are four types of closure. The first one is the push-fit closure. Here is the example of the push-fit closure, because if you want to close it, you have to push and fit. As for the screw-threaded closure, you have to twist or spin the closure to open it and to close it. There are other variation of the screw-threaded closure, which is push down and turn closure. As you can see here, you cannot open the closure by the normal twist, but you have to push and twist the closure in order to open it. The other variation is the squeeze lock and also the flip top. The flip top is here. It is a screw threaded closure, but it have a flip top. The push down and turn and the squeeze lock is used as a child resistant closure. The third closure type is the heat sealed closure. The example of the closure that use the heat sealed properties is the sachet, the film lids, and also the tablet blister pack. The final types of the closure is the folded closure or plus with the glued. This is the closure that's commonly used in the cartons. The closure is the important part of the packaging because it is the interface between the product and the environment, and it is also critical interface between the product and the consumer. Thus, it must meet a number of requirements that we will discuss in the next slide. Okay, this is just a picture example of the types of closure that we will discuss before. For the closure's requirements, it must not contaminate or degrade the content. It must be compatible with the container, and it must be able to withstand processing conditions such as sterilization or force application upon tightening the cap. It also must be capable of withstanding vibration and temperature fluctuation during the transportation, during the storage, and also during the consumer's rough handling. It also must provide adequate seal until the product content are ready to be used. It also must be convenient and safe to be removed by the consumer, and it's safe for the consumer use. It also may need to include the child-resistant features, which restrict the access to the potentially harmful product for the children. It may need to include the tamper-evident features to indicate whether the container has been interfered prior to the purchase. It also must often be resealable. The resealable meaning that the capable of the retaining an adequate seal once resealed and withstand the repeated opening and closing. Lastly, it must contribute to the overall aesthetic design of the pack. So the closure requirements in the slide before is the end of our lecture. These are the references that I've been used to make this slide. You may refer to this lecture for more understanding. Thank you for listening my video presentation. I hope you understand, and if you are not understand, you may contact me via the email or WhatsApp. Thank you.